So now the structures about the study design, what Dr. Santan Gopal has just now discussed, I'm not going to discuss in detail anything about this, but you must realize that research question is the starting point of any research work, and these are the various characteristics which should be there in a research question when you are formulating a research question. And those details I will not go, but only thing that you must remind your research question whenever you are formulating it. If you are formulating your research question properly, probably your other design will be really proper. So population, in any RCT, there should be 5 components should be there. Population, intervention, comparison, outcome and time. These 5 things should be there. If you have included, which goes by the acronym PICOT, then probably your research question is really appropriate. And this I will not go because the time is short, so I will not go in detail. But just look at this. There is a research question which is in a published article in Journal of Cataract and Refractive Surgery. This means if you see this 2 sentences and all 5 elements are there. Like in eyes having phacoemulsification, that is the population. Ringer lactate solution, which is whatever your intervention, compared to BSS plus, means that is your comparison. PIC. O is the outcome measure, which is now you see the endothelial cell count. The significant difference in endothelial cell loss. And finally the time, T, PICOT, the time frame which is in the 6 months time period. So it means you know that all 5 elements are included in this. So with this kind of research question, if you are formulated, probably you are really in the right track. Now, I thought that given time about the statistics, what can I deliver in 12 minutes, including research question. So I thought probably the best thing is to give you some guideline how to choose a statistical test, and just to see whether whenever the statistical test is being done, let's say you are reading a paper, any statistical test which has been performed is proper or not. So that is one help that will provide you this lecture. Second is when you are doing research yourself, which test to be done, that also will decide. It's not that you collect the data and then you go to a statistician and tell that, okay, now run into all battery of tests and whichever is showing significant, I'll report and I'll say that my result is significant. Okay. And so anything, means any research, you have to have the null hypothesis, that is presume that there is no difference between the two, and then alternate hypothesis. If it is you cannot prove null hypothesis, it means the alternate hypothesis is correct. And there are 2 types of error which are there: type 1 error, which is also known as alpha error, wrongly rejecting null hypothesis, and type 2 error, beta error, failure to reject null hypothesis. Now, to understand this, the basic principle of which test is appropriate for a particular type of research question, you must know that basically there are 2 types of data. One is qualitative or categorical, and the other one is numerical or quantitative. In numerical and quantitative, you should also realize that this data can be parametric, numerical, or the parametric which follows the Gaussian curve. If it is not following a Gaussian curve, it means it is non-parametric data, or if you don't know that what is the distribution of the data set, you should presume that it is non-parametric. But there are certain tests which are done to find out whether your data set of qualitative data is parametric or not. Okay, so having this background, now you just try to understand these 5 tables, which are really very simple. And in this, first thing that you should know that what type of question you are going to answer. That is there a difference between the groups which is unpaired? Unpaired independent samples drawn from the same population. What do you mean by unpaired group? Means those 2 groups has got no connection with the, or one group measurement is not interfering the measurement of the other group. Means what do I mean by that? Suppose I am measuring certain parameters, say blood sugar. In this population I have 2 samples. So sample A, sample B. These 2 are different samples. So these are unpaired because when I am measuring from sample A and measuring from sample B, these are not getting affected by each other's measurement. So if this kind of question we are going to answer, comparison, then this table will be applicable. Then what you should know, what type of data you have. I told you 2 types of data, numerical or categorical, that you will really, if you hear my long lectures, then probably you will realize that, but I presume that everyone knows that. So if it is numerical data, and in numerical if it is parametric data, numerical, then in that case you have to find out whether you are comparing two groups or more than two groups. If it is two groups, then the test is unpaired t-test. If it is more than two groups, ANOVA. Don't try to remember this. It's just try to understand the basic principle. Where I'll give you at the end one reference where you will find all 5 tables, and it's just 2-page article, nothing more than that. So, the 2 is, if it is 2 groups, unpaired t-test, more than 2, ANOVA. If anything is showing positive in more than 2 groups, then you do post hoc analysis. These are certain tests for post hoc analysis to find out which group out of the multiple groups is showing significance. If it is numerical data, non-parametric data, then if it is 2 groups, man will be more than 2 groups, Kuskal values. Again, same thing, the post hoc analysis. If it is categorical data, not the numerical data, the 2 groups or more than 2 groups, chi-square Fisher test and the chi-square. So this just try to understand the basic principles. If you have understood this table, how to go about further, then your half job is done. Now the next table, which is only difference is there a difference between the groups which are paired? Now paired means they compare more sets of observations on a single, such as time series, before, after and crossover. Suppose if I want to see, let the previous one unpaired, 2 groups, effect of one medicine, 2 medicines, 2 intervention. So group A, group B, given one medicine to A, second medicine to group B, and then take the measurements. That was unpaired. Now paired means if I want to see the effect of medicine, which is the over time series. Say before medicine, what is the intraocular pressure? Give medicine, record intraocular pressure before, give medicine, and after that, after 2 hours, 4 hours, 6 hours, whatever your wisdom says, you decide that, and that is the paired group. Means the second measurement or the third measurement is influenced by the first measurement. Understood this? So this is paired group. So if this type of group is there, then this table will be applicable. But afterwards, just follow the same principle. Numerical data or categorical data. Numerical, parametric, non-parametric. Same distribution. If it is parametric, then 2 groups, paired t-test. If more than 2 groups, repeated measures ANOVA. If it is otherwise non-parametric, 2 groups, man-Wilcoxon test, more than 2, Friedman's test. Again, if there are multiple groups, then you have to do the post hoc analysis. Now here, categorical data, 2 groups, more than 2, Mecken-Marr test or Cochrane-Q test. Now, this one, the common mistakes what people commit, means the researchers also, even in established journals, in standard journals also you find mistakes. People don't realize the difference between unpaired t-test and paired t-test. All they consider that t-test is all the same. So that is the major mistake. That if the group is paired, they don't do paired t-test, they do t-test, which is unpaired t-test. Second mistake that they do, that more than 2 groups, what they do, suppose there are 3 groups, A, B, C. They compare A with B, t-test, A with C, t-test, B with C, t-test, and then report that, which is incorrect. It should be multiple, where is more than 2 groups, whatever test is written here, either ANOVA or repeated measures ANOVA, based on what groups you are dealing with, paired or unpaired. So that test, if you find significance in this test, then do post hoc analysis and find out which group is showing significance. Okay. And the third one is the association between 2 variables, because the research question may find out, means you may say 2 variables, whether is there an association between the 2. In that case, say numerical data, categorical data. If it is numerical, both parametric, then Pearson's correlation coefficient. And here the R value that you find out. R, it can be from -1 to +1. -0 is no significance, no association. But -1 and +1, both perfect association. Only thing, one is direct relation, other is inverse relation. And if it is non-parametric, then this test. 2 by 2, if categorical data, if 2 by 2, then risk ratio, odds ratio. If more than 2, then chi-square trend, logistic regression. So this, just understand again this table, try to understand. So now here, what people commit mistakes. I think I'll go to the next one, then I'll come back to this. Now the fourth question can be, is there agreement between the assessments? Such as, say there is an instrument measurement, new instrument which has been introduced into the market. You want to compare with the gold standard. Something is gold standard, you try to compare that. Screening, so such as screening test, diagnostic test, or rater validation. Now this type of, if the question is there, then you have to use this table. If it is numerical data, then intra-class correlation coefficient. And if you are doing a graphic method, then blank Kalman plot. And if it is categorical data, then this test. Now here, what people commit mistakes? Common mistakes. Suppose, say, they want to, there is one instrument which is introduced into market recording intraocular pressure, new one. Now they want to compare with, because then you have to validate this. You have to compare with gold standard. That gold standard is, right now is applanation tonometer. Okay. In that applanation tonometer, they take measurements of one patients in the applanation group with the one instrument, the same patient with the new instruments, and then they take the mean of both the readings and then they do t-test, which is absolutely incorrect. The second thing, that they will take measurement and then they draw the Pearson's correlation coefficient. And they find out Pearson's correlation coefficient 0.9, perfect correlation, so both instruments are validated. Again it is wrong. Because time doesn't permit me to explain that why it is wrong, but that is wrong. So in that situation, this is the test, intra-class correlation coefficient, which should be done, and that is the right test. And the final one, is there difference between time survival trend? Because the survival graph that you have to draw, but this survival doesn't mean that death has to take place, because usually this test was introduced when for cancer patients, because in that time when the survival for 5 years or 3 years was the real success which was considered, not like now what it is today. So but in any other field, for any event to occur, say like glaucoma, if you have performed anti-glaucoma surgery, so what is the time that you want to see the end result, that when, say suppose you are starting with 50 patients, then after how many years, so suppose 1 year, how many grafts fail, after 2 years, how many grafts fail, after 3 years, how many grafts fail. So that is the event which is occurring. So if that type of situation you are dealing with, then this is the data that you have to follow. This is the table that you have to follow. Now after explaining all this, I told you in the beginning that don't read all this, don't try to recall and don't try to memorize this, otherwise you will get confused. This is the reference which is freely available, which is open access. So just log into www.jcor.in. Sorry, I'm wrong. This is the Indian Journal of Ophthalmology. So it's Indian Journal, so www.igor.in, and in that you find out this reference. Only 2-page editorial written by us, and in that you will find all 5 tables and little more extra explained about this, whatever I have taught. Thank you very much for your patient listening.